In section 8.7, we're graphing radical functions, and I also did one inequality. So we're going to go through and first identify the general shape of the function. We're going to find the starting point, and then we will plot one point to give us a little bit better idea of where the graph goes. The square root, if there's not a number here, it automatically means the square root. Those are the half of parabola. It's a sideways parabola. It's only either the top of it or the bottom. This one is positive in the front and positive inside, so it is the top half of a parabola that opens to the right. So I need to find this little starting point right here. Normally the parent graph would start at the origin, but since this has some numbers in here, it's going to affect the graph. This number, remember, inside is x minus h. This moves the graph left or right, and it moves it the opposite direction of the sign. So since this is +1, this graph will be shifted or translated left 1. The number that's tagged on at the end, the constant, that is your k. That moves it up or down. This is negative, so that shifts my whole graph down 3. So if I start at the origin and move left 1, down 3, that is my starting point. That is this point. My parabola is going to go up to the right, we already decided. The 2 in the front is a vertical stretch, so if I stretch it vertically, it's going to be taller like that. But to get a little bit better idea, I'm going to plot a point. Be conscious of what you're substituting in. So I'm going to have to, whatever number I choose for x, I'm going to have to add 1 and then take the square root. And you can use your calculator and get decimals, but it's going to be easier for me if I do something that I can easily take the square root of. So I'm going to pick x is 3, so that when I add 1 to it, 3 plus 1 is 4, and I can easily take the square root of 4 and get a whole number. So I'm going to choose 3 for the x coordinate. I need to substitute that in to get the y value for that point. So if I substitute 3 in, (3 + 1 is 4, square root of 4 is 2, 2 times 2 is 4, minus 3 is 1. So when x is 3, the y coordinate is 1. Be careful to keep in mind which point it starts at. It started at this one down here. It has this shape, and it's going to go through that point. So it looks something like that. The second one that I chose to do is a third root. And if you remember, for the parent graph of a third root, that shape is, I just called it a wiggle. It is horizontal and it goes up on the right. This one has a negative in the front. That negative on the front flips it across the x-axis, so it flips it this way. So if it flips it like this, then this one that went up to the right is now going to come down to the left, and this one that came down to the left will flip up and go up to the right. So now it's going to look like that. Again, now I have to find the starting point. For the cubed roots, the starting point is the middle of the wiggle. So I'm going to find that point. I know the general shape. I'm going to plot one more point to get a little bit better idea. This one moves to the right 3. There's not a constant at the end, so it doesn't move up or down. So it just moves to the right 3 and will be on the x-axis. So there's the middle of it. It's going to come like this. I'm going to plot a point. So I have to take the third root. My favorite cube is 8. So I'm going to try to make this inside be 8, which means that x would need to be 11. So I kind of work backwards to decide which x I want to plug in. If I put 11 in for x, 11 minus 3 is 8, and the third root of 8 is 2. So I get negative 2 times 2, which is negative 4. So over 11 and down 4. So sure enough, it wiggles the way we thought that it was supposed to. We anticipated. This side goes down. It's like half a parabola again. And then the other side, instead of the parabola being the other half up here, this one's flipped over and it goes this way. That's what the cubic graph or cube root graphs look like. And the last one is an inequality. So you have 2 extra steps to do with these inequalities. The first one is look at your inequality sign and decide if you want your line, or not if you want, but if your line needs to be solid or dashed. Since this has the or equal to, it's going to be a solid line. It's a square root, so it is the half a parabola. Positive in front, positive x inside, so it goes up to the right. So I'm going to graph it just like I did the first one, and then when I'm done graphing, I will find a point to test and decide which side I need to shade. So inside moves it to the left or the right. This is -1. Left and right is opposite, so my graph will move right 1 spot. There's not a number at the end, so it does not move up or down. I'm going to plot a point. If I want to take the square root of 4, then 5 minus 1 would give me the 4, so I'm going to put 5 in for x. 5 minus 1 is 4, square root of 4 is 2. So I plot the point 5, 2. It starts here, that's my starting point, and it goes up through that point. So remember, when we shade, don't go past the starting point. So it's going to be cut off right here. And then I either shade below my graph or above my graph. We're going to pick any point that's not on our curve to substitute in the inequality to see if that point is a solution or not. So let's choose 4, 0, or 4, 1. So I'm going to test the point 4, 1. That means I substitute 4 in for the x, 1 in for the y, and I see if this inequality is true. So that gives me 1 is greater than or equal to the absolute value, or sorry, the square root of 4 minus 1. 1 is greater than or equal to the square root of 3. Well, the square root of 1 would be 1, and the square root of 4 is 2, so this is somewhere in between 1 and 2, closer to 2. So I don't even need to get my calculator out. I know that 1 is not bigger than that, so this is not true. So here's the point that I tested. If that is not a solution and it's below the graph, then none of the points below the graph will be solutions. Therefore, the solutions must be above the graph. So I'm going to go back to the point and then shade above the graph from there.